Hi, welcome back to Mr. Slover's Math. Today we're going to talk about adding and subtracting polynomials. So like terms have the same base and same power or exponent. So we're just refreshing your memory. So here's my example, 3x plus 4y equals 7x. The same power and base, which is the x, I add my coefficients 3 plus 4. Likewise, if I have negatives or if I have a different variable, I can do the same thing. Over here in red, I have a non-example. Yes, they both have the letter x, they both have the same variable, but my powers, my exponents, are different. So that makes them not like terms. So what we're focusing on today with adding or subtracting is they have to be like terms. Our powers, our exponents, have to be the same to combine them with a different term. When you add or subtract polynomials, the powers do not change, only the coefficients. So I wrote this here, and then I wrote it again right here because that's how important it is. I need to make sure that I don't accidentally add my powers together. Okay? The only thing changing is my coefficients. Now, if you notice in example 1, I've got a lot of highlighting. So for these, I went ahead and I highlighted my like terms. If you don't have a highlighter, you can underline, you can circle, you can box, you can squiggle, you can cloud, you can heart, you can do whatever helps you. So it says add the following. So I'm telling you that you're just going to add them. So 5x squared plus 6x squared. Same base, which is an x. Same power, which is a 2. So I add the coefficients. 5 plus 6 gives me an 11. The x squared stays the same. And then in blue, I highlighted the other like terms, which are my constants. Which remember, a constant is just a number. So negative 3 plus 8 gives me 5. If you're not good with negatives, you should be using your calculator. Letter B, same idea. I highlighted my like terms. I have a y to the fourth minus 3y to the fourth. Remember, this y to the fourth does have a coefficient. Even though it's not present, it's there. It is a 1. So we're going to do 1 minus 3 to give us the negative 2y to the fourth. And then I have a negative 3y plus 2y. Well, that gives us a negative 1y or negative y. And then 7 plus 8 is going to give us 15. Now, these are in standard form. Remember, standard form is your largest exponent, your largest degree first, and then the next one, and so on and so forth. So for this one, y to the fourth is larger than y to the first, right? This degree is higher, 4 power of 1. That's why it goes first. Over here, same thing. I highlighted my like terms, and I highlighted my like terms. Okay, so addition is very straightforward. When you get into subtracting, you got to do something a little bit different. So when subtracting polynomials, you have to distribute the negative 1. Sort of, what does that mean? Well, if I have a negative and then parentheses, it's really saying negative 1 times 4x and negative 1 times positive 1. So if I were to distribute that negative 1 there, which you've seen distribution before, it would simplify to negative 4x minus 1. So if I see it in what we're doing today, if I see this, here's how we apply it. This first part stays the same because I'm not subtracting that, right? My subtraction is right there. So I'm subtracting this quantity. So I'm going to subtract an x, and I'm going to subtract the 10, okay, which is the same as saying negative 1 times x, and negative 1 times 10 is going to give me what I just stated. So this first part stayed the same, and then I just subtracted. Okay, this is not my final answer. Okay, all I did was show my distribution. I didn't collect like terms or anything like that. So example 2 now is asking us to subtract the following polynomial. And I've got 3 steps. The first one is that the first set of parentheses is going to stay the same. The second step for success is I need to distribute the negative 1, and then the third step is to collect like terms. Now, for purposes of this class, I'm only giving you 2 sets of parentheses. Okay? Other math classes may give you more than 2, in which case you may have to slightly adjust these rules or these steps for success. So the first parentheses stayed the same. All I did was rewrite it without the parentheses. Then I wrote a -1. And I did these on all the ones that I had to distribute a -1, or that I'm subtracting. So I realized that I'm really distributing a -1, and each arrow is showing that I'm distributing a -1. -1 times 6x squared, -6x squared. -1 times 8x, -8x. And just like before, I have highlighters, so I highlighted my like terms. 5x squared minus 6x squared is -1x squared, or -x squared. And then the -8x and the -3 didn't have anything to combine with, so they stay separate. And I chose to put it in standard form right away, so I didn't have to rewrite it. So it says -x squared minus 8x minus 3. That's in standard form. My largest power, my largest degree is first, and then the next largest, and then the next largest, and so on and so forth. Letter B, same idea. Now it's just a trinomial subtracting from a trinomial. 3 terms minus 3 terms. So I distributed. I just have the arrows down below because I filled up the space up top. And I highlighted my like terms and went from there. Now letters C and D is the same concept, but I did my collecting of like terms without a highlighter. So I demonstrated how I would do it if I were to just underline or squiggle my like terms, because I didn't have access to a highlighter. First set of parentheses stays the same. Second one I distribute, or I multiply -1. -1 times 19x squared is -19x squared. -1 times -1x is positive x. And remember, you can use your calculator. You can do -1 times -1 to tell you what that is. Okay? Or if you need to check, that's fine. Then from there, I'm collecting my like terms and writing my answer in standard form. Same thing on this one. I underlined, squiggled my like terms, and then I wrote my answer. And then example 3 says add or subtract the following polynomials. So now you have to decide when do you distribute and when do you not. So you are only distributing -1 on the subtraction problems. So this says I'm subtracting, right? I'm taking this quantity and I'm subtracting this quantity. So the first set of parentheses stays the same. The second one I distributed -1. So -1 times 3h squared, -1 times h. Then once again, if I don't have access to a highlighter, I can underline, squiggle, circle, whatever your like terms, and I end up with -9h squared. And maybe you think, well, how is that possible? H minus h. 1 minus 1 is 0. So that means those h's are now gone. I'm not going to put an h there because it's all gone. 1 minus 1 is 0. And then in letter B, I have a plus sign in between my two sets of parentheses. So I'm just looking for like terms. I didn't even have to rewrite it. If you want to, you can rewrite it without the parentheses, but that's totally up to you. So I just circled, underlined my like terms, and I made sure to put it in standard form, largest power / degree first, and then the next one, so on and so forth. So when you subtract polynomials, distribute a -1. I'm requiring you to rewrite the whole problem, and then identify your like terms and collect them. When you add, all you're doing is looking for like terms. And remember, when you combine like terms, your exponents, your powers do not change, just the coefficients.